Hi, welcome back to another episode of BBQ Thermometer Hacking. In this episode, we'll actually start to look at building our Python application and using the steps that we took in our previous session, interacting with the GATT tool to begin to learn how to do the same thing using the PyGATT library, which is essentially a wrapper for GATT tools. So we'll be connecting up with our thermometer device, begin to interact and access the temperature data, and then ultimately save that data into a CSV log file. Okay, let's get started here. So first I'm just going to go ahead and create a new directory for us to build out our project in here. So I will just create a directory and I'm just going to call mine barbecue blue code, and then I will just change into that directory here and go ahead, and I'm going to be using VS Code on my end, but if you're using a different IDE, feel free to open it up in there. To do it with VS Code, we can just type code dot after we change in that directory, and that'll go ahead and open up that folder for us with Visual Studio Code. Okay, so now that we have the editor open, I'm going to go ahead and create a virtual environment. It's just always a good idea to create a virtual environment just to prevent any dependencies for this project that might overlap or change anything for other projects. And so just allows us to keep all of the third-party packages that we might install for our particular Python programming project all in one kind of isolated space. And so to do that, we're just going to open up a new terminal. And the command you're going to be typing is Python 3, then -m, v-environment, and then v-environment. So this is just going to create the virtual environment inside of a folder here called v-environment. And I'll run that, and so now that's going to go ahead and it's created the virtual environment for us. I'm going to go ahead and activate that virtual environment, and to do that I'm just going to hit Control-Shift-P. That's going to bring up this command interpreter here, and then what I want to do is actually select this Python select interpreter, and as you'll see here, it gives us a list of several of the different ones for maybe different projects that I'm working on, and the one that I'm after is actually the one that's located right here in this folder here, in this current folder under v-environment bin Python. And so I'll select that, and after selecting that, I'm going to just go ahead and open up a new terminal. So you can just close out of this, reopen up a terminal window here, and the shortcut to do that is just going to be Control-Shift backtick. When we press that, that will open up a terminal window for us, and it will automatically activate that virtual environment for our project so that all of our commands will be installing into the virtual environment now. So the first package that we want to install for our project is going to be the PyGATT project. And so to install that, just using the documentation, it says that we want to install this using the pip install PyGATT GATT tool command. And so this is going to ensure that we get the version that supports the GATT tool as our backend for connecting up. That was that tool that we got to explore earlier in the previous session. So I'm just going to run that. That's going to go ahead and install those packages into our virtual environment. Let's go ahead and create our initial Python file. So to do that, I'm just going to come up here and go to New File, and this is going to be our main program. So I'm just going to call this barbecue app.py and press enter. Let's look at the steps from a high level of what it is that we're actually going to be doing with the program. So we're going to connect up with the device, then we're going to be writing that connection key to the 29 handle. We'll then also be writing the enable notifications to the 34 handle. After that, we'll then subscribe and listen for the notifications of the real-time data that's coming through, and then as those notifications come through, we'll need to process and save that real-time data. So let's start with connecting with the device, and we'll work through these. I've just gone ahead and imported the package that we installed earlier, the PyGATT package, which we're going to be using. This essentially is a wrapper around the GATT tool that we were using in the previous exercise. So to initiate that, I'm going to create an adapter variable here, and I'm just going to say adapter equals, and then I'll do PyGATT dot GATT tool backend, and essentially this will create us a adapter that ties in and links up with the GATT tool. It's important to understand that to write these values, we're going to need to store them in slightly different format than we were using in the previous session. So when we were writing to those handles, we were able to previously just write the values as their hex values to the handles. In Python, we're going to actually need to convert those from their hexadecimal format into a decimal format, and then I'll be storing them in something known as a byte array on here. And so to do that, I'll show you how to convert one of them. If you remember, we were writing one handle, which was, I believe, 0B01, and then it was maybe 8 zeros. So to convert this into the correct format that we're going to use, I'm going to actually just create and store this as a variable, and I'm going to be calling this enable notifications. And what we have to store this as is a byte array. And then in here, we're actually going to give it a list, and the list will be a list of the decimal representations of each one of these values. Okay, so now we're ready to go ahead and get started with starting the connection. And so to do that, I'm just going to put all of this inside of a try block, and just to make sure that I don't forget, I will type in our finally, and what I want to happen here is I want to go ahead and start the adapter. So I'm just going to do adapter.start, which will start up our interface with that GATT tool. If there's any issues or anything like that, and just to make sure that it closes everything properly, I'm going to force that there's always a finally and do an adapter.stop in that finally, so that regardless of what happens, the connection always gets closed down gracefully here at the end of this code block here. I don't actually need to do an except for this because I don't plan to do anything if there's an exception that happens for this example. So we've gone ahead and started the adapter, and then the next thing that we want to do is I found that the PyGATT tool can be a little flaky sometimes, at least it was for me when I was trying to establish a connection. So I ended up having to wrap it a couple times in a try except sequence here to get it to retry when it fails the first time. And so I'm going to do a try and then an except, and inside of this initial try here, what I want to do is set a device equal to adapter, and then we're going to use the connect command. And so we will connect, and for what we're connecting to here, it is wanting the address, the MAC address. And so we've stored this already in a variable called BBQ Mac, so I'm just going to select that. If you didn't store yours in a variable, you could just put in a string representation, so in quotes your MAC address in here. And so I'm just going to put the BBQ Mac, and then the other part we can put in here is a timeout, and so I'll just put out a timeout of 20. And now, like I mentioned, the PyGATT tool is a little bit flaky sometimes, or can kick a few errors out, at least mine was. And so what I've done is, if you do happen to get an exception here, I just have it go ahead and retry this one more time, just running the same command. I might let me know that it did run into an issue, so I'll say couldn't connect to the device, retrying, and then we'll go out and try and reconnect with that. Okay, so I think that takes care of the initial connection. I'm just going to go ahead and move our comment code up into this try block here, just so that we can kind of track along where we are for these other parts. And so the next part that we have here is that we do need to send the connection key to that 29 handle. And so to do that, I'm going to do this all inside of this try block here. I'm just going to use the device that we have now and do device dot, and what we want to do is we want to write to the handle, and so we just do a device dot character write handle, and the handle is the first thing we need to provide. And if you remember, this was the 29 hex 29 handle, and then we provide the value that we want to write. In this case, I have a variable that I created above called connect key that is similar to this. It's just a byte array that has the decimal representation of that connection key stored in it. And so I'm going to just specify that here. And then after I do that, the next part that you'll want to do is enable the notifications by writing to that hex 34 handle, which is the next spot that we see here. So it's going to be a very similar command, so I'm just going to copy and paste that here, and instead of writing to 39, we're going to be writing to 34. and the value that we're going to write is instead of that connection key, we want to use the enable notifications byte array that we set up here. And so that's going to write that value, which, if you'll remember, was that 0B01 and then zeros value that we were using in the previous session. So after we do that, that should then have connected to the device and started the enable notifications, or at least started the process of notifications. Okay, so now that we have our code here, I'm going to go ahead and just test it out and make sure that we can connect with the device with what we have so far. If you run into some issues with timeouts, like I did, just make sure that you have the device disconnected from the VM. And so I had to actually open the VM back up and disassociate the Bluetooth dongle adapter from the device there, and then that allowed it to be re-enabled here on my host machine. And so let's go ahead and test out the functionality of this so far. So I'm just going to add a few print statements here just so that we can see what's going on as this is running. So before this sends in our connection key, I'm just going to have it print out pairing with the device. And then after it does that and it enables those notifications, I will print out connected with the device. And then finally, just so that when it gets through running this, that it doesn't just end and disconnect, I'm going to have it wait for us to enter a key to quit the program. And so it's going to essentially just get to this point and wait for us to enter in some form of a key before it then finally stops the program. So let's go ahead and test out our code and see if it is able to connect up with the device. So I will type in Python barbecue app and it will start to run. And normally the way that I've seen this work is it'll sometimes time out on the first one. If not, it will connect. In this instance, it looks like it connected okay. We see we've got our pairing with the device, then it connected, and now we are connected. I can see there's a solid light here, and it's waiting for us to press any key to quit. So I'll just press a key, and as you can see, it then closes out and our connection disconnects. Because we have this finally block, it does shut down the connection with the adapter and stops it. Okay, so now we are ready to do the final bit of code here, which is going to be this subscribe and listen for notifications of the real-time data. To do that, I'm going to put this all inside of a try block, and I'm also going to put an except here. And essentially, I ran into where this does run into an error sometimes. If that happens, we just want to simply run it again inside of that except, just to make sure that it does get ran. And so the way that we do subscriptions is I'm going to type device, then I'm going to type subscribe, and what this takes in is a UUID. And so previously we had been using those handles. UUIDs is just a longer string that we can use to reference that particular characteristic or service. And so if we take a look at our services running on that custom one, we'll see that the the main service name here is this 65520. That's in decimal anyways, but the hex representation of that essentially is this long value here. And what we'll see is that under that we have several different characteristics, and the one that stores the real-time data that we're interested in subscribing to is just this 65524. And so we're going to actually give it in the hex representation. So instead of this ending in FFF0, we'll just simply change that to FFF4, and that will allow us to then subscribe to the data coming through the real-time data notifications. And so I've already gone ahead and copied out that long value here, and so I will just paste that in, and then the final thing that we need to provide is the callback, and this is essentially the function that's going to get ran every time new notification data comes in. So we haven't wrote this function yet, but I'm going to write a function called handle notification that runs every time there's a new notification of updated temperature data that comes through. And so as mentioned before, we do run into issues where this times out, just kind of glitchy sometimes, and so I just add another try except in here that will essentially run this again and then one more accept, and on this one I'm just going to pass. So after we do this, this should pretty much be set up and ready for us to write this handle notification function. We actually need to move this input sequence to the bottom. We want this really to be the last thing down here at the end. So I'm just going to copy and paste that down here. I've just gone ahead and copy and pasted in this handle data function. I went ahead and renamed it to handle notification because that's just the name I gave it for callback down here. And you'll need to also just import this hexlify package, so you can do a from bin ASCII import hexlify, and that should be on here. You'll see the from bin ASCII import hexlify. So just go ahead and throw that to the top of your file, and then once you've imported that, we should be able to just test this and see if we have that hex data coming through. So I'm going to go ahead and run my program here and give it a moment to connect up with the device. So as we can see here, it's going to connect up and pairs with the device, and it is now connected. So now we're going to just wait a moment. It takes just a moment, about 10 seconds or so, before the actual temperature data starts to flow through. But once it starts flowing through, then it is in real time practically. So we'll give it just a moment to start reporting on the temp data. Okay, and so now the temperature data is actually coming in, and just to show this again, I only have one probe plugged into this device right now, and the probe is plugged into the second spot. So if I touch the probe on here, we should start to see those values change, just like we did in the previous example. We can see we have the values are now changing in here, and if I let go of that, our value should start to go down. So we are receiving the data now, and so the next step will be to actually parse and read that data, get that data into the correct format. I'm just going to create a little helper function here that's essentially just going to convert from Celsius to Fahrenheit for me. And so to do that, I'm just going to come in here and create a function and call it Fahrenheit. So I'll just type that out, and then we will take in the Celsius degrees as our input. And all this is going to do is return a value, and it's going to calculate that value as essentially, it's going to be an integer. It's going to round the Celsius value, and it's going to take Celsius, and the conversion for that is simply take Celsius, you times it by 9 divided by 5, and then you add 32 to that number. So the way that I'm going to actually process and handle these temperatures is I'm going to be using a for loop, and I'm going to be looping over the byte values that are returned in this data that we get back here. And so to do that, first I'm just going to go ahead and get rid of this old print statement here, and I'm going to be inserting here a dictionary that's going to kind of hold all of our temperature values. And so I'm just going to call this temps, and I'll just create an empty dictionary here that I'll be using to save those temperature values in. Then I'm going to do a for loop, and essentially what I want to do is loop over and be able to select slices of the bytes that came back in that value, and then be able to interpret those as little Indian, if you remember correctly. And then once we get that value out, converted out, we'll then be able to pass it through our Fahrenheit function, and then ultimately receive the degrees in Fahrenheit for each of the probes. So to do this, I've created a for loop, and so I will loop through, I'll do for I in a range, and this range, we're going to start with 0, and we're going to work our way up to the value of 8, and we're going to do an increment of 2. So this essentially is going to cause us to do a loop of starting at value 0, then it's going to go to value 2, then it's going to go to value 4, then it's going to go to value 6, and then it's going to stop the loop after that. And so we'll see how this works for us. So now we're ready to begin looping through this and getting each of of the Celsius representations for each temperature probe. So to do that, I'm just going to call this Celsius, and then I am going to use this feature that's part of the integer built-in data here, and I can do this int.fromBytes. And here I will actually be able to specify what we want is we're going to be taking the bytes out of this value here. So I will say value, and the bytes that we want from there, we will actually want a slice of that. So I'm going to do I, so that'll be our starting value, and then I plus 2 will allow us to grab just the temperature data for a single probe, for the current probe that we're on. And then the final thing is we need to tell it the format. The byte order for this, we learned last time that this uses little endian. So I'll type in little here, and then the final thing that we need to do is divide this by 10. So if you remember, before it would give us an integer number that we then have to divide by 10. So I divide that whole thing by 10, and then ultimately what I want is just an integer value from all of that. So I'm going to wrap this whole thing in integer. Okay, so now that we have the Celsius, I want to go ahead and convert that into Fahrenheit, and so I'm just going to create a variable here. I'll call it F degrees, and we will run that Fahrenheit function that we created above, and it just takes in Celsius as its input. And so when we run that, that will then convert those Celsius into the Fahrenheit degrees. Now, if you are Celsius already, then no need to do this conversion here, and you can just use Celsius in place of wherever we use F degrees for the rest of this part here. Now I want to actually save the temperature data for this particular probe, and as notice, this again is going to loop through each of the probes and read in just that section of bytes, convert it, and get the temperature value for that particular probe. So I'm going to use the F strings here to actually create the keys in the dictionary temps that we created here to store each temperature probe. So I'm going to actually store these, and I want to store them with a key, and I'm going to use F strings, and so for that I've just called these probe and then dash, and then I'm going to actually include in the curly braces here is where we conclude the variable part of this. And so what I want it to be is an integer representation of what our current count is. So if we're on value, say 0, I'm going to take that, I'm going to divide it by 2, and then I'm going to ultimately add 1 to that value. So what this does is this loop is going to run again a total of 4 times because it starts at 0, and then it ultimately will run up to 6 because when it gets to 8 it'll tell it that it's too much and it'll stop. So it will run up to 6, and what that does is I will be 0, then the next time it runs I will be 2, then the next time it runs I will be 4, and then finally I will be 6. And so it's going to take the value of I, so the first time this runs I will be 0, and we'll do 0 divided by 2 is 0, and 0 plus 1 equals 1, so we'll call that probe 1. The second time this runs, I is going to be equal to 2 because we have a step of 2. So we started at 0, we add 2, and now I is 2 the next time this runs. So when I is 2, we'll take 2 divided by 2, so this will equal 1, and then we will add 1 to that, and we'll store that value as probe 2, and so forth. So using that, we then just simply set this temp equal to our F degrees for that. And so now we will essentially have built out a dictionary that has the temperature values for all of the probes stored in it that we can then access. Now that we've saved all of the temperature data in a dictionary here, we can go ahead and just, as an example, once it's finished, print out what our temperature data is. And so I'm just going to simply print out temps, and we'll see how this shows up now. So now when we run our program, we'll get to see, does it convert the data, convert it into Celsius, and then ultimately change it into the Fahrenheit. So I'm going to go ahead and run the program. Make sure that you've saved it if you haven't already, and I will go ahead and start running. We'll wait. It should connect up here to the device. Give it just a moment. Here we are. And we're now connected. And now, if you remember, we got to wait just a moment, and then we should start to see our temperature data coming through. And as you can now see, we have the values coming through in the degrees that are shown. So right now I only have, again, probe number 2 is connected, the other ones are disconnected, so they just have this default big value here, but we can see that probe 2 shows 79 degrees, and on our device we can see that it shows 79 degrees currently. So we are now decoding that information properly, and again, if I come out here, hold on to the probe, we should start to see that probe 2 goes up just as the value goes up on the device itself. So it's going up. Now we're in the 90s, and I can take a finger off of that, and it should go back down. So we are now correctly parsing and retrieving that data. Now I want to go ahead and show how to just output all of this data into a CSV file, and we'll be adding also a date timestamp so that we can do time tracking of the temperatures and how they change over time. So to do that, we need to go ahead and import CSV. This comes with Python, so you don't have to do any pip installs or anything. You're just going to type out here import CSV, and then the other one that we want to import is going to be our date time, and we're not using this hexify anymore, so you can go ahead and remove that import if you still have that in your file. Okay, so and to start here with writing out to the CSV file, what I want to do is go ahead and just create a CSV file with the headers in it. And so I'm going to use a context manager, which just means here as we start with this with, and then I will open, and I'm just going to call mine temperature log.csv, and then we need to specify that we want this to be in write mode, and we'll give this a name as CSV file, and get rid of that extra 0 there, don't need that. Then we will type out writer equals, and we do CSV dot writer, and then we will pass in that CSV file that we are using with inside this with block here. So now we have a CSV writer, and what we want to do is we want to write just one row to it, which is going to be our header row. And so I will say writer.write row, and then inside of here we're going to go ahead and give it the column names, or the actual names of each column. And so the first one is where I'm going to actually store the timestamp information. So I'll just type out timestamp. The second one will be probe 1. The next one will be probe 2, probe 3, and probe 4. Now these can be any name you want. Just the name of these does not matter. It's just whatever you want it to show for that first row in your CSV file. So after we do that, we will after this runs, essentially it will have created a CSV file, and it will have wrote out this first row here for us that just contains the header information for each column. Okay, so now that we have the header data writing out to our CSV file, what we want to do is make it to where every time one of those new temperature notifications comes through, we write that data to the CSV file. And so to do that, what we want is the date and time whenever this notification came through, so that we can track the temperature data over time. And so to do that, we've already imported the date time library, and what I'm going to do is actually just change our dictionary here so that it includes by default already a entry in here for the timestamp. And so I'm just going to create inside of our dictionary one key already, and what it's going to be is a string of the datetime.datetime.now object here. So what this is going to do is it's going to get the current time, and then it's going to convert that into a string and then store that under the timestamp key. So now we have a dictionary that has called temps, that has a key called timestamp, and then it also has these other 4 keys with the name of probe 1, probe 2, probe 3, probe 4. And so what I want to do is, after it captures all of that data, I just want to write that out to the CSV file. But instead of writing to it, I want to just append to the file. So what I'll do is I'm going to use the context manager again and do a with open, and then I'm going to say temperature log again. We want this to be the same file, CSV, and then this time, instead of opening it with a W, which was just for writing, I'll open it with A, which will allow me to append to the file without overwriting anything. So it's just going to add to the end of the file now, and I'm going to call it as a CSV file. We're going to link that up with our writer again, and so we will do CSV, we'll say writer equals CSV dot writer, and this time it's the CSV file again, and then we will do a writer dot write row, and this time what I'm going to do is use list comprehension to just pretty much output these fields into here. And so I will do temps and we'll call field, and we'll say for field in temps. So this is just going to loop through everything that's in the dictionary here, and then essentially include that as an entry in our CSV file. So this will include the timestamp as well as the 4 temperature values that are stored in that file, and write those out to the row. Let's go ahead and test this out and see how it works. So I'm just going to run our app again with Python barbecue app and give it a moment to connect up. And what we should see is, as this ran, we saw that it created this temperature log.csv file, and you can see that we put in the code here for it. After it gets connected, it's going to write those initial headers out to that file, and it did that already here. Now that we've seen the enter any key to quit, we know now that it's actually writing those temperature values to a file. So if I touch the probe here, we'll see that the temperature value changes on here, and each of these should be getting logged with a timestamp so that we can actually see how this data changed over time for the device. I'm going to go ahead and press any key to quit, and now we've stopped logging to the file. Let's go ahead and open it up. And if we just take a look here, we can see all of those values got wrote out. We got the timestamp, the values for each of the probes, and only probe 2 again is connected, so we see the 79, and then we saw as I touched it, the value goes up here. We can also open up this CSV file with the LibreOffice Calc program on here, which I've done, and that just allows us to actually see that actually in that tabular format here. Makes it a little easier. And I just went ahead and imported this as a date-time format, and then told it to display just the date and then the second format here for me, so we can see here that temperature data over time. Just to show you what we can do with this data, I've just taken the date timestamp and gone ahead and split it out to where we've got date in one column and time in another, and I'm just going to try to build a quick graph over the time data of our temperature here. So I'll just select everything except for that timestamp, come up here to the chart, and I want to do a line chart, and I want to have it by points and lines. And if we come under here, that's fine. I'm going to leave everything else there. What I don't want in here, though, is the time to be on there, and I don't want this probe 1, 3, or 4, since they're pretty much don't have any data for those. I think they'll just skew the data in the chart, so I'm going to remove those and then come under here and click finish. And so what we get is now we get an actual chart that shows our temperature data as it rose as I was touching the probe, so we get some kind of visualization here that we could use, and as you did use this more, you could have all probes of these to see how the temperatures change. Thanks for watching today's episode. We were able to begin to write our Python application using the PyGATT utility and work through kind of all of its quirks and get the data ultimately flowing in. So we were able to connect up with that device, pull down the data, parse it, convert it from its little Indian format into a nice Fahrenheit temperature. We wrote that information out to a log file, and we're able to then see how we could start to do some analysis on that file afterwards. In our next session, we'll be taking that data and writing it into the cloud database, and then begin to build some more interesting web applications around it. So stay tuned until next time.